Hi, this is Dr. Rickert, and this video is about statistics. I'm going to be talking about frequency distributions, measures of central tendency, and measures of variability. Okay, so first of all, a frequency distribution is essentially a picture of your data. You've gone out, you've collected some data. Let's say you gave some kind of a test to a number of people, and one of the first things you might want to do is look at a picture of where everybody is. So on a frequency distribution, it's something like this. Your dependent variable goes down here along the horizontal axis. So if we gave somebody some type of a test, this could be their score on that test. And then the vertical axis is the number of people or the proportion of people who got that score. So it's just showing how many people got each score. And one of the most common distributions, this whole thing here is a distribution, one of the most common distributions is called the normal distribution. It's sometimes called a bell-shaped curve. It has a few other names as well. But in the normal distribution, many things that you measure in the world are normally distributed. For example, if I measured the height of everybody at NEIU, we would get a nice normal distribution. And it means most people are in the middle, right here. And the farther away you get from the middle, the fewer people you have. You have a very small number of people way below the mean and a very small number way above the mean. And it's symmetric. So that's one type of distribution you can get. Another type of distribution that's not too uncommon is a skewed distribution. This one is called positively skewed, and this one is called negatively skewed. And it's kind of like you took a normal distribution and you took one of the tails and pulled it out to one side. So most of the people in your data tend to be skewed. In this case, they're skewed towards the lower scores, and there's a very small number who are way out there on the high end. And you can have the same thing in the opposite way. In the negatively skewed distribution, most people tend to get high scores, but then you have a very small number who got low scores, and it pulls the tail in one way or the other. And a good example of a positively skewed distribution is the income distribution, because your income can't be less than zero, but it can be infinitely high. So if you look at income distribution in the United States, you'll find that most people are in the low to middle range, but there's a small number of billionaires way out there that pull that tail way out to the right. And finally, another type of distribution is the bimodal distribution, which suggests that you have two separate populations of people. It has two humps in it instead of just one. So for example, if I had a class at Northeastern Illinois University and a kindergarten class came to visit us and I measured everybody's height, we would have a bimodal distribution. The Northeastern students would have a normal distribution on the high side, and the kindergarten students would also have a normal distribution, but they would all be lower. So we would get a bimodal distribution because we'd have two separate groups of people. When you collect data, usually one of the first things you want to calculate is a measure of central tendency. This tells you where most people are. So you want to get a general idea of where most people are in your data. By far, the most common measure of central tendency is the mean, which is also known as the arithmetic average. You're probably already familiar with it, but I am going to talk about it a little bit. There's the mean, the median, and the mode. Okay, so for the mean, this is the formula for it. You don't really need to know what that formula means. Someday in the future, you'll learn more about that. But it essentially means that you add up all the scores and you divide by the number of observations. Okay. So in this example, I have some data here. There's some numbers. And to calculate the mean, you would add them all up and then divide by the number of observations. If you want, you could pause the video here and try calculating it to see if you could do it. I'm going to do it for you. This means the sum of x. Each of these scores is called an x. This means the sum of x, which is just adding all of these scores together. And when you add all those scores together, you get 42. There are 7 scores, 1, 2, 3, 4, 5, 6, 7. So the number of scores is denoted by the letter n, and that is 7. So the mean is 42 divided by 7, which is 6. Pretty simple. Now I'm going to talk about the median, which is another measure of central tendency. It's not as popular as the mean, but it is used quite a bit, and eventually I'll tell you specifically when it tends to be used. The median is the score where half are above it and half are below it. So it's the one right in the very middle. In order to get the median, you order all the data from highest to lowest, or you could also do lowest to highest. The one in the middle is the median. So you have an equal number of observations above it and an equal number below it. If you have an even number of items, there will be 2 in the middle, so you take the average of those 2. In other words, you add them together and divide by 2. Okay. The median is also known as the 50th percentile. It's where half of the people scored higher and half scored lower. So for example, in the same set of data, if we had these numbers, in order to get the median, you would order them from highest to lowest, and I've done that here. I've just reordered the same data from highest to lowest, and as you can see, the one in the middle is 6. There are 3 above it and 3 below it, so the median is 6 in this case. And finally, the mode is not used as often, but it is the most common score. So you just count how many people got each score, and the mode is the one that's most common, or in other words, the score with the highest frequency. So in this set of data, what is the mode? It's 8, because there's 2 8s. Oh, no, it's actually... Hi, I'm Dr. Rickert, and I'm going to be talking about statistics in this video. I'm going to talk about frequency distributions, measures of central tendency, and measures of variability. A frequency distribution is essentially a picture of your data. When a scientist goes out and collects data, often one of the first things they'll do is they'll look at the frequency distribution just to get a general idea of where everybody is. This is a picture of a frequency distribution. In a frequency distribution, you always have your scores along the horizontal axis here. So let's say you had given a test to a bunch of people. The scores on that test would be along this horizontal axis. The vertical axis is always the number of people, or it could be the proportion or percentage of the people. But you want to see how many people got each score. And one common distribution is the normal distribution. This whole thing here is called the distribution. It's the distribution of your scores. In the normal distribution, it's shaped like this. It has a very specific shape. It's sometimes also known as a bell-shaped distribution, and there's a few other names it goes by. And the main thing is that most people tend to be in the middle. And the farther away you get from the middle, the fewer people you have. You have a very small number of people who are way below the average and a very small number who are way above the average. And it's symmetrical. Okay. So many things in the world are normally distributed. If I was to measure the height of all the students at NEIU, I would definitely get a normal distribution because height tends to be normally distributed. But another type of distribution that's not as common but still pretty common is a skewed distribution. Here's 2 different skewed distributions. It can be either positively skewed or negatively skewed. A skewed distribution is like a distribution where you had a normal distribution and then you took one tail and kind of pulled it out. So in a positively skewed distribution, most of your observations tend to be in the middle to lower end, but then you have a very small number of observations that were really high, and so that tail gets pulled way out there to the right. In a negatively skewed distribution, it's the same thing, but the tail gets pulled out to the left, to the lower scores. A good example of a positively skewed distribution is income. In the United States and many other countries, income is positively skewed because your income can't be less than 0. There's a minimum for it, but it can be infinitely high. So most people tend to be in the low to middle range, but then we have a small number of billionaires way out there who pull that tail way out to the right in the case of income. And finally, you can also have a bimodal distribution. That is one that has 2 bumps in it. It's kind of like 2 normal distributions next to each other, although it wouldn't necessarily have to be 2 normal distributions. It could be 2 different ones. But a distribution like this suggests that you have 2 separate populations, and you really probably should not be combining that data together. You should probably disaggregate it and look at the 2 separate populations separately. So now I'm going to talk about measures of central tendency. Central tendency is a measure that tells you where most of your observations are. And there are 3 common measures of central tendency: the mean, the median, and the mode. By far the most commonly calculated one is the mean. You're probably already familiar with it. The mean is also known as the arithmetic average. And this is how you calculate the mean. This is the formula. Don't worry about the difference between the sample and the population. Someday in the future you'll learn about that. But this is the summation sign. X stands for an individual score. So this means you add up all the scores and then you divide by the number of scores, which is n. It's very simple. And I'm just going to quickly calculate one for you. You probably already know how to do it, but I'll just calculate it for you so you can see. Or you can pause the video and calculate it on your own if you want to make sure you're doing it right. But the first thing you do is you add up all the scores. That's what this means, sum of x. Each of these scores is an x, and you add them all up. So if I add up all these numbers, I get 42. Okay. Then you want to divide by the number of observations that you have, and you can see I have 1, 2, 3, 4, 5, 6, 7 observations. So n is the number of observations, which is 7. So the mean is 42 divided by 7, which is 6. So it's very simple. Another common measure of central tendency is the median. Okay. The median is the score in the middle. So in order to get the median, you order all of your scores from highest to lowest, or you could also do lowest to highest. Okay. The one in the middle is the median. If you have an even number of items, you're going to have 2 in the middle. So then you take the average of those 2 in the middle. You add them together and divide by 2. The median is also known as the 50th percentile. It's where half scored higher and half scored lower. So here's another example. In order to get the median, you first have to order these from highest to lowest. So I've done that here. I've just taken the same data and ordered it from highest to lowest. And the one in the middle is 6. 3 scored higher than 6 and 3 scored lower than 6. So 6 is the median. The mode is the most common score, the score with the highest frequency. It's the score that most people got. So in this particular case, what is the mode? It's 7 because 2 people scored 7 and all the other scores only have 1. So in this case, the mode would be 7. So now we're going to go back to the normal distribution. One nice thing about the normal distribution is the mean and the median and the mode are all the same. The mean is the arithmetic average, and it will come out to be right in the middle of this because you have an equal number of people at all the different scores above it and an equal number below. The median will also be right in the middle, and the mode will be right in the middle. But in other types of distributions, this is not true. That's why we sometimes have to calculate something other than the mean. In skewed distributions in particular, these 3 things will be different. If we look over here at the positively skewed distribution, the mode is always at the peak of the curve, so that's going to be there. Because we have, let's talk about income, where a few billionaires pull that tail out there to the right. They're going to pull the median up just a little bit because they're a small number of people. Let's say we had like a whole bunch of regular people and then Bill Gates happened to be in our sample. Bill Gates would pull that tail way out there to the right because his income would be way higher than everybody else's. He would only pull the median up a little bit because he's just one person, and the median doesn't look at how much you have, it just looks at the number of people above and number of people below. So the median would only shift a little. The mean would shift a lot though, because that billions of dollars that he has, if you plug it into that formula, it would pull the mean way out there to the right. So when you have a skewed distribution, the mean is not really a good representation of where most people are. The median is a better representation. So that's why you usually do not hear people talk about the mean income. You usually hear them talk about the median income, because when you have a skewed distribution, as you do with income, the median is a better representation of the central tendency. Finally, we're going to talk about variability. After you've calculated your measure of central tendency, usually the next most important thing to know is a measure of the variability. So this you might not be as familiar with as you are with the mean. So I'll give you an example to start off. Suppose we have 2 classes with 3 people in each class. In class number 1, we give a test, and in class number 1, there's one person who scores 0, one person scores 50, and one person scores 100. If you calculate the mean of those 3 numbers, you will get that the mean is 50. In the second class, one person scores 45, one scores 50, and one scores 55. If you calculate the mean of those 3 numbers, again, we get a mean of 50. So these 2 classes have the same mean. If we only looked at the mean, we would think these 2 classes are equal. But if you look at the individual scores, they're really not. Because in class number 2, everybody was very close to the mean. But in class number 1, they were all spread out. One person was way above the mean, and one person actually scored a 0. So class number 1 was much more variable. Another way of showing you the variability is in a distribution like this. The red distribution has very low variability. In both of these, both the blue and the red distribution, the mean is 0. So most people scored 0, but in the red distribution, everybody was very close to 0 and hardly anybody scored very much above or below 0. Whereas in the blue distribution, it's more spread out. While it's also centered at 0, there are more people above and more people below. So the blue distribution has more variation. So there's a couple different numbers we can use to show variation: the range, the standard deviation, and the variance. And the variance is actually the same thing as the standard deviation. It's just the standard deviation squared. But I just wanted to let you know about that in case you come across it. The easiest one is the range, so I'll talk about that first. The range is simply the largest score minus the smallest score. So in this set of data, what is the range? You might want to pause and calculate it for yourself. The largest score is 12, and the smallest score is 4. So the range is 12 minus 4, which is 8. Now I'm going to show another one that's similar but a little bit different. In this set of data, what is the range? Well, all the numbers are the same, except I changed that 10 into 100. So now the range would be 100 minus 4, which is 96. So you can see the range is much greater for this distribution than it was for this distribution. So while the range is a good measure of the variability, it's not perfect because it can be affected by an outlier. An outlier is a data point that is very different from everything else. You can see in this distribution, everybody is pretty similar to each other except this one person who's way, way higher than everybody else. So that having an outlier can really increase the range drastically. So that's why more often than the range, scientists will often calculate the standard deviation. The standard deviation is a little bit more complicated, so I'm not going to actually go through the steps of calculating it. I'm just going to describe it to you. Someday when you take a higher level class, you will learn how to calculate it. But you take each person's score, you subtract the mean, then you square the difference, and you add them all up, and you divide by the number of observations. So it's kind of like the average deviation. The range looks at just the lowest and highest and completely disregards everybody in between. The standard deviation, on the other hand, looks at everybody's score and how much it differs from the mean. So if you have one outlier, that's going to have a huge effect on the range and will have less effect on the standard deviation. And then finally, the variance is simply the standard deviation squared. With all of these, the higher the number, the greater the variation.